Hello and welcome to our last example on how to use Excel to implement simulation models. With this last example, I want to demonstrate how we can do or implement queuing models using simulation as well. In reality, often the arrival time and the service times don't follow closely enough theoretical distributions. And when that happens, often it is simpler sometimes to just run a simulation to explore the queuing model, the queuing situation. So let's look at number 4 to illustrate how that could be done, still keeping things fairly simple though. Denton Savings Bank is attempting to improve customer satisfaction by offering service such that the average customer waiting time does not exceed 2 minutes and the average queue length is 2 or fewer customers. That's what they would like. The bank gets an average of 150 customers each day. Given the existing situation for service and arrival times shown below, we want to figure out, does the bank meet their criteria? Okay, so we have a distribution for service times, we have a distribution for arrival times, and these can come from actual surveyed information. Someone sits at the bank and times and keeps track of arrival times and service times because it could follow some other probability distribution, right? All right, so let's do it. So there's nothing fancy about this queuing model, basic, but let's see how we can simulate the process and get information that way instead of using theoretical formulas. Okay, so we're going to have customers 1, 2, 3, 4, all the way down to 150 rather. Copy it down. They say we get 150 customers. Beautiful. Okay. And then we are going to have to randomly, according to the probabilities, generate an arrival time between arrival time and a service time. So for that, we'll of course get the lower limits of the distribution and the upper limits. Upper limits, as before, is going to be the sum of everything up to that point, the cumulative probability. I'll fix the first one as we've done a couple of times now. Please make sure you check the previous examples thoroughly before you attempt this one. This one's definitely, I think, the hardest of all of them. So we have our right sides here. The left side of each interval is simply the previous right side, as we've done before. Of course, I have to press my recalculate button every time because I set my formulas to manual. Then we're going to copy our arrival times here for, let's say here, copy arrivals time between arrivals rather, so that VLOOKUP is happy. It needs to look to the right. We're going to do the same thing over here. Let's do the sum. No, I touched something by accident. Sum function, cumulative probability with the first one fixed. Close the bracket. Copy it around. Of course, recalculate. And you can see, you can check by hand as well what it should be. Some people prefer to put it in by hand, but we don't have to. Reference the end of the previous interval. I'm doing it quickly because we've done it multiple times now. And this is just the copy of my service times. Okay, so we need those. Just like before, it's the same always. Okay, so we're going to generate a time between arrivals as, well, let's use the insert function, search for VLOOKUP, and we're going to use a random number, of course, just like always. We're looking into the table for time between arrivals, and we're looking forward to column 3, and there it is. And you can copy that down if you want to just recalculate a few times and see, ooh, bad things happen because I always forget to fix my table, right? It happens. It is okay. Most of the time we will spot something weird is happening, and then we can recalculate the formulas. You see here it's generating times between arrivals. Beautiful. We're also going to generate service times in exactly the same way, so we might as well do that now. VLOOKUP, I'm going to use a random number, and I'm going to look up in the corresponding table. I remember to fix it this time. I'll look forward to column 3, copy that down, test it. Looks pretty good to me. Okay. Now, let's start filling in these columns. These aren't necessarily the only columns that you might want, but it's just a good starting point. You can always add your own columns if you feel like it. So arrival time. Let's actually zoom in a little bit here. There we go. That's nicer maybe. Arrival time. So here I want to keep track of the timestamp throughout the day, throughout the 150 customers. Starting at time 0, the first person arrives 3 minutes after the start. So they will arrive at time 3. Now I'm going to manually put these in for now before we worry about a formula, just to get an idea of what we're doing here. We're keeping track of the timestamps of how this day progresses. So what was it? Minutes? Minutes, yes. So 3 minutes into the day, the first person arrives. Then the next time between arrivals is 3 minutes again. So at minute 6, the next person arrives. Then at minute 9, the next person arrives. 4 minutes later, so at minute 13, the next person arrives, and you get the idea, right? Like so. Now, of course, we can't do this by hand. There's 150 of them. That is not the point. So what can we do here? Well, in general, this guy, oops, not that guy. This guy is going to be the previous time stamp plus the time it takes for customer 5 to arrive. We see we get our 16. Now we can copy this all the way up, except recalculate. Except this first one has a little bit of an issue, right? It can't look earlier because there's no space for the calculation to occur. So for that reason, we need to have a row that initializes everything. A customer 0, if you will. They don't take any time to arrive. They do literally nothing. But then our formulas are going to make a little bit more sense. Move it down. So now, let's just do a couple and then we'll see how it looks. Recalculate and see if it makes sense. So this isn't actually a customer. When I eventually calculate my average wait time, average queue length, don't include those zeros, but for the arrival time formula, I kind of need to, because it references a previous arrival time. So I need a dummy customer to temporarily arrive at time 0, but actually do nothing because they don't exist. So I see that the arrival time for customer 6 is the previous arrival time plus the time it took between the arrivals. So at minute 14, customer 5 arrived. 1 minute later, customer 6 arrives. So at minute 15. So it's good to just double check. Yeah, it looks okay. 0 minutes later. So customer 4 arrived right at the same time as customer 3. So again, 10 minutes and so on. Okay, so that looks pretty good. So far, so good. So the start of the service, again, is a timestamp. So let's say here, time stamp. Oh, let's maybe do it in one line here. Timestamp. This one is also a timestamp. Actually, all of them are. All of these ones are timestamps. Let's color them something to help remind myself. It's not input, just something, maybe something like that. Keeping track of the actual minute clock. Okay. So when does the service start? Well, let's just do it by hand again. The service starts for customer 1 as soon as they arrive. No problem. The service starts for customer 2, we don't know, because it really depends on how long customer 1 is there. I'm just going to bold this to see the customer numbers. There we go. So I kind of have to finish customer 1 a little bit, at least until the end of service. So its start of service is 4. How do I calculate the end of service? Well, it's when it starts plus the service time. So I'll just put a formula in there, because that doesn't seem to be too difficult. So the start of the service plus the service time. Okay, now fair enough, this is not a timestamp, the service time, right? Let's get rid of that. There we go. That's an actual number of minutes that I add to get the new timestamp of 6. Now I have a better idea that customer 2 starts their service. Well, they arrived at minute 7, and by that time, the previous customer was already done. So they can start their service at 7 as well. And they will, of course, take... Ooh, I don't want to recalculate. I'm going to manually put these in. I like my numbers. They're going to take 7 plus 1, 8 minutes. Yeah, we have to copy this formula down. But if I recalculate, I'm losing all my numbers. And I like these numbers. Doesn't really matter, but I don't want things to keep changing on me. For me to make sense of what the formula should be, because these are a little weird. So it's nice to have some numbers that don't change, right, all the time, which is why we changed to a manual formula calculation. Okay, so customer number 2 arrives at minute 7. Because the previous customer was already done, they can move right along to start their service. It takes 1 minute. They end at minute 10. 8, not 10, 8. Then customer 3 arrives at minute 10, and I see that the previous customer was already done, so they can move right ahead. Why is that bold? No, don't make it bold. I know it's an impressive number, but it's not bold. Minute 10. It takes them to minute 11 to actually finish their service. Okay. Customer number 4 also arrives at minute 10. But when they arrive, the previous customer is busy being serviced. They can't move to the terminal to get serviced because they have to wait for that to finish, which happens at minute 11. So they can only start their service at minute 11. There's no delay in the transitions. There's no transition time. So by doing this, okay, let's do a couple more. Then they're done at minute 12. Then the next customer arrives at minute 14. Well, by comparing it to the previous end time, I see I can move right along and start my service right away. How long is that service going to take? 3 minutes. So I'm done at minute 17. I know I'm doing it by hand, but trying to get an idea of where do I look to figure out this number. That'll then that'll lead me hopefully to the formula, the calculation in the background. So let's do one more customer. Let's do one more. Customer number 6 arrives at minute 15. Where do I look? I compare this 15 with the previous end of service time to decide what they have to do. Because the 17 is bigger, they have to wait. They have to wait for what? 17. The larger of these two numbers. So it seems like this one has to be the maximum of this number and this number. Then they'll take 18. They'll finish at 18. Next one starts at 19. If I copy this down, it's not going to calculate. Okay, at this point, let's just copy these formulas. Where was my formula over here? Copy those formulas down. Copy that formula down. Because we have to recalculate to do anything. And let's see if it makes sense. It's not the best version. Let's just run it a few times and hopefully we get lucky. That one's pretty okay. Okay, so now I've implemented my formulas. I want to see, does it make sense? Let's double check these numbers. Customer 1 arrives at 2. Of course, there's no one there. Goes all the way to minute 5 to finish their service. Previous customer conveniently arrives at minute 5. They can go right away because as they come up, the other customer leaves. They go all the way to minute 8. This is not a very interesting one. The next customer arrives perfectly. Okay, great. Can we get something that doesn't arrive perfectly? Wow, they keep arriving perfectly. Okay, here we go. Customer number 6 is done at minute 16. Customer 7 arrives at minute 17. We see, oh, this one's bigger, so they can move right along. Okay, so let's create something more interesting so we can actually check if the formula is doing what it should do when people arrive before the service time is done of the previous customer, and this one is. Right? Customer 3 arrives at minute 3, but the previous person is still taking all the way to minute 4, so they have to wait to minute 4. Does it happen again? Not really. It's not that common, is it? I see one more, but I'm pretty confident in my formulas. Over here, yeah. Okay, one more. Customer 2 arrives at minute 1, but customer 1 is still in service all the way to minute 5, so they have to wait to minute 5. Okay, so everything looks pretty good. Looks pretty good. Okay, I'm feeling good. We've done a lot of it. Now the wait time and the queue length is what we're actually interested in. So all of this was just to help me get to the important columns. Okay, wait time. So if I look at this example, the customer is starting their service, let's say arriving at minute 1, starting their service right away. How long do they wait? 0 minutes. They don't wait, they move right along. Customer 2 arrives at minute 1. Their service only starts at minute 5. How long do they wait? 4. The difference. Customer 3's arrival is minute 4. They have to wait until minute 9. They wait 5. So it's, why bold? I don't know. It's pretty obvious, I hope, that the formula is the start of service minus the arrival time. That is how long they wait. Now we're going to have to recalculate and then generate a whole bunch of new numbers. Let's get something with actual arrival. Ooh, look at this one. They get backed up really fast. Arrival time versus start of service, 4. 2 versus 9, 7. 2 versus 12, 10. Beautiful. And then it's because they arrived so quickly. Look at them. Minute 1, minute 1, minute 2, minute 2. It backed up a little bit because their service times were longer. So things got backed up a little bit, and then eventually it sort of fixes itself down the line. All right, good. We have our wait times. It's not always going to be that bad, right? Look at that one. Now let's pick something like this maybe. This is a good one. To figure out the queue length. This is the number of people waiting in line, and this includes the current customer. Why is some things bold and others not? It's weird. Let's get rid of that. So if I look further down, let's say here at customer 5, as customer 5 comes in, they arrive at minute 13, but they can only start their service at minute 16. They, among others perhaps, form part of the queue, part of the line that are waiting. So the current customer. So what we're asking here, or what we're trying to figure out here and keep track of, is when customer 5 arrives, including them, how many people are waiting? How many people are waiting, including them? When customer 7 arrives, for example, are they waiting? No, they're not waiting at all. Is anyone waiting here? No, this customer 8's waiting a little bit. They are in line as well as maybe someone, other people, right? We have to figure that out. Okay. So let's just do it by hand from the start. And this one's a little bit more tricky, but as we do a few by hand, hopefully we will start to see where do we look, and then we just make a formula to do what we just did. Okay. Customer number 1. Customer number 1 is arriving at time 4. Start service right away, which means they just walk right on. 0 people in the line, right? 0 people waiting. Customer 2, same thing. They arrive, they start their service, they don't even stop, they walk right to the front. So when they arrive, there is no one in the line. 10 as well, customer number 3 as well, arrives at minute 10, moves right along, 0. We'll get to something more interesting in a second. Why bold? Why? It's random cells being bold. It's bothering me. Okay, customer number 4 arrives at minute 12, starts service at minute 13. So that person is definitely in the line waiting. Are there any more in the line, or is it only that one? It's only that one because the previous person already went on to their service, to start their service. By the time customer 4 arrives at minute 12, the previous person has already moved on. So there's no one waiting. Okay. So it seems, I'll do more, but it seems that I'm looking at these 2 columns. Somehow, let's figure it out. Customer 5 comes in at minute 13. They do wait, but are there more people waiting? Doesn't seem like it, because as they arrive, the previous customer moves to the front, so they're the only one waiting. Now it might be I just randomly let these numbers generate, right? It might be that we don't get a queue length more than 1 ever in this example. However, we've learned that we're looking at these numbers in these two columns. So yeah, it's not the best. So let me just delete that, because we're going to generate a new one. Let's just generate something that's a little bit more interesting. It's random. I don't know what I'm going to get, so I have to recalculate a few times until I get something that's going to give me a queue length. Oh, this is a good one. Okay, let's do this one. All right, let's have a look at these randomly generated numbers to try and figure out what our formula will be for the queue length. So if I look, for example, at customer 9 here, let's skip the first few because it's not very interesting. Customer, not 9, row 9, customer number 3. They arrive at minute 5, but they have to wait quite a bit, right? Because when they arrive, the previous customer hasn't even gone to their service to start their service yet, because their service only starts at minute 6. The customer before them, they have already started. So the queue length in this case is 2. Bold. It's impressive, yeah. Customer number 4 arrives at minute 9. They can't go on right away. The previous customer hasn't gone either, but the one before them have, because they went on at minute 6. So 2 again. Next customer. They arrive at the same time. Also minute 9. They can't go. You see their service is later. The previous person's service is later. The one before that service is later. So now the queue is up to 3. Oh, did I just recalculate? Anyway, we get the point. I can't go back. There's no going back. I accidentally calculated. It happens. So the formula is going to be, I'm going to use a COUNTIF function. Oh, it was there. Haha. Okay. Let's put it up here. I want to count if any of these numbers from the very beginning to my current customer, if it is greater than the arrival time. That cell. Okay. Now, unfortunately, in Excel, if I have a specific number there in my criteria, it's okay. But if I have a cell reference, then I have to put the inequality in quotations, then an and symbol, and then the cell reference. Otherwise, it doesn't pick it up. So let me just copy these. Oh, that doesn't work, right? I have to fix the start so that it doesn't drag along with me, just like before. Let me just calculate a few of these and see if the selections at least are good. And then we can generate a few until we get, ooh, look at this. This is pretty nice. Until we get some numbers we can test if it's doing what we want it to do. So, customer number 1 arrives at minute 4, starts right away, 0 queue. Perfect. Customer number 2 arrives at minute 7, starts service, 0 queue length. Perfect. Customer number 3, arrives at minute 8. They have to wait themselves for minute 10, but no one else is waiting. One person waiting. Okay, good. Next customer arrives at minute 8 as well, they have to wait themselves, and the previous person is waiting for minute 10, so 2 people in the queue. Next customer arrives at minute 10, they have to wait. The previous person is waiting for minute 12, but as they arrive, the other one at least has gone in, so 2 people in the queue as well. Let's go a little further here maybe. Customer number 10 arrives at minute 27. The other person before them has just gone in. They're the only one waiting. Okay, looks good, looks good. Everything's good. So let me double click on this again to show you. I want to count how many of the start service times are greater than my arrival time. So if you do the insert function, it's not going to be as nice and convenient. Just check when you do a cell reference, you have to have the and symbol and stuff. So when we did it by hand, we were looking at these times. Now the formula is just doing exactly that. And we have to look at all of them because it could get backed up very far back. Okay, we are ready. Let's copy this down to customer 150, recalculate, and there we go. So now, let me zoom out a touch maybe. There we go. Now, based on one run of this simulation, I can calculate the average wait time. Which one was that? That was this one, not the 0 up there, right? That was the initialization 0. If I include that, then the average will be a little skewed, and we don't want that. Average queue length is going to be the average of the queue length, not that initial 0. Down to the last customer. Ooh, the queue length got a little long here at the end. Ooh, that's unfortunate for them. Okay, so we F9, recalculate a little bit. It's a little slow here. There's a couple of things to do, or maybe my laptop is just slow. And I see some fluctuations, yeah, quite a bit, right? What do we do? Well, this is just one run of the simulation. We do a data table to run the simulation many times. Let's say that's our simulation run. And in this case, we have our wait time as well as our queue length. We have multiple things that we want to measure. Ooh, let's maybe shift it over by 1. There we go. Okay, so we want to have run, let's say 200. Is that what the question wants? I should probably check. Oh, they don't even say. 200 is pretty standard, but the question should say, I admit. So 2, 3, 4, 5, 6, 7, 8, all the way down to 200. I think my laptop is slowing down a little bit. For some reason, who knows why. Where are we now? Oops, we're on the right here. I want to color this green because I like green. It's how I learned an output cell should look. So I'm in the habit. I have the habit of doing that. Okay, so my wait time is going to be referencing the average wait time at the bottom here. My queue length is going to reference the average queue length at the bottom there. I have a dummy cell because data table is not necessarily doing what I want it to do. Now I'm going to select all 3 of these columns all the way down. We'll get there. Come on. There we go. And then I just like to look at the top. Oh yeah, my laptop is slowing down. Come on. Why? You can do it. Oh, it's not happy at all now. Very slow. It's okay, we're almost done. And then I'm going to say data. I realize I don't have the big mouse cursor. Hopefully you could see it. Whoops. What if analysis, data table, column input, dummy cell, go. Not going to do anything. I have to recalculate, of course. Yeah, it's a little slow right now. That's okay. So then we could do this, but for 200 simulation runs, and then simply get the average, average of the data table values. And again, same as we've done all the time. Make sure you understand the previous examples first. Same thing for the average queue length. Get it from the data table numbers. All the way down. 200 is just an arbitrary number, so Excel doesn't slow down too much. Like so, and then we can recalculate. Takes a little bit longer, but you see hopefully the fluctuation isn't nearly as bad as it was previously. So the average wait time seems to be a little below 5. If I look at this cell over here, we can even make it bigger for you. A little under 5 minutes, sometimes over. Of course, there's some variation still because my sample of 200 isn't, or not sample, my 200 simulation runs, it's still a pretty small number. Seems to be around 5. Let's not say under. Close to 5. And the average queue length, I wasn't looking at that to be honest. A little over 2. Yeah, a little over 2. Okay, so now we can go back and say, well, what would they like ideally? They don't want the waiting time to exceed 2 minutes. Well, it does, unfortunately. And the average queue length is way higher than the 2 you're looking for. No, so sorry, backwards. Sorry. The waiting time was around 5 minutes. They wanted to not exceed 2. Yeah, sorry, that's not happening currently. The average queue length, 2 or fewer, we're very close to that. We're very close to 2. So that isn't bad. Maybe we could give extra training to the person doing the service so that they could be faster. Maybe they're chatting with the customer too much. I don't know. And then you can adjust it and then run a simulation for your new one to investigate if that was better. So Excel isn't designed as simulation software for queuing models necessarily. You get other applications for that specific purpose. But it is, to me, very interesting how we can use a spreadsheet software application for interesting things like simulating customers arriving at a bank. That's interesting. So with this example, I wanted to just give you a taste of what can be done, and perhaps it's certainly more than I thought could be done initially. And it's very interesting that you can explore this further if you feel like it. All right. With these 4 examples, hopefully we get a good idea of how to use Excel for simulation purposes. Let me know if you have any questions. Until next time.